Hello, this is Eric Miskell with EMSNOW. I'm here at the booth at Productronica 2019. Have Blake with me from Essentium. We're going to start right with that. Before we get into what you do tell about what you're named, Essentium. There's a story.
Yeah, sure. Well, first of all, thanks for speaking with us today. We're excited to peel back the layers a little bit on how 3D printing or additive manufacturing can actually play, I think, a stronger role over time in the EMS space. So we're excited to talk about that. But first, to your point, Essentium, it's a great name. I love it. The main reason why we chose Essentium is because adamantium was already taken. And as you may recall, adamantium is, of course, the material that makes Wolverine Wolverine. And so we chose Essentium because it sounds like it is strong and tough and essential, like plutonium or uranium, any of these materials. And in fact, it speaks to the core of our company. We are a materials-first company. So my background is in materials science, and so before that I was a designer. I worked at Caterpillar and John Deere and some of just these classic manufacturing companies, not in the EMS space, right, for sure, but just companies that build stuff, And so I decided to sort of get upstream of that and so try to help the designers of tomorrow with better tools. And so got together with some folks and we launched Essentium. As a materials-first company, designed really to try to help tomorrow's designers make amazing stuff. And so that's where the name came from.
No, that's a great story. I forgot about the Wolverine face.
Yeah.
My sons would be disappointed in me. It begs the question, so 3D additive manufacturing, whatever you wish to call it, 3D, we will. EMS, 3D manufacturing, how does that work?
Yeah, so great. Actually, EMS is kind of an interesting industry the more I learn about it. We're certainly in a learning mode, certainly at Essentium, as we take a look at the industry sort of writ large. EMS seems sort of, kind of a moment of transition in some ways. As you sort of look at megatrends and, certainly, global political issues and manufacturing challenges country to country, what we see is that actually the flow of goods and services country to country is ever more challenged instead of being ever easier, which is sort of a little bit interesting when you think about it. Right. But so where 3D printing can play a role, like other digital tools, is to help manufacturing solutions like the EMS sector really make devices with more agility, more flexibility, more customer choice baked in, and shorter lead times. So specifically, what that means for us is addressing the factory floor. So if you look at the factory floor, what you see are machines that are making other machines, and you see machines that are making consumer devices and planes and trains and shoes and cars and computers. But those machines also need to use tooling and fixturing and jigs and work aids and inspection equipment. And much of that equipment can actually be printed and in fact should be printed. Yeah, so Essentium's really trying to sort of say, hey, with better materials, with a faster 3D printer, we can actually unlock new economic models to lower the cost of manufacturing. Yeah. And so we think that gives us a compelling role to play in EMS.
Right. That's interesting, right? So, and I think you're absolutely right, having worked in EMS before, right? That you can see a lot of applications for it on there. And some of those don't need to be qualified necessarily. The material has to be qualified, right? But as far as the application, if you're talking about, something to run down the line and whatever that might be, and I'm thinking from screen printers, and there's so many. Hadn't thought about this till we started talking, and reflecting on that. So, what kind of feedback are you getting? Where are you seeing? Kind of where do you start, right? Where do the applications to get your toehold?
Yeah, certainly. So when we were, kind of walking the halls of Productronica 2019, when we were walking the halls today, what we saw, actually, interestingly enough, were several equipment vendors, kind of in the SMT space, and also in, actually device assembly, which are using additive manufacturing to help them with their jigs, fixtures, and tooling, and also inspection equipment. One great example was a little pallet that was 3D printed that was used for pin inspection. And so you could place the pins and the boards on this pallet, and the pallet goes into the inspection tool, and the tool optically looks and checks the assembly of the semiconductor items, and the 3D printed solution is prepared quickly. It is super low cost. It is accurate for the inspection application, and so that's a great example. Another example we saw was for cassettes. For cassettes, right? So these cassettes, of course, are filled with chips and diodes and resistors and so forth. And so the cassettes are being stacked and loaded into trays and towers for loading and storing the cassette safely. But we see 3D printed little guides for the cassettes so that they don't fall onto the floor, or they don't fall one cassette onto the next cassette, if the automation is perhaps still being tuned, things like that. So you see, in the factory floor context, many examples where additive manufacturing can play a role. But what's actually even more interesting than all of that I just mentioned is, if you look at high temperature applications like reflow ovens, so the pallets, for instance, and the caps and the spacers. So what we're seeing now at Essentium is, as we focus on high temperature fiber reinforced polymer composites that are also ESD safe, we could actually start to look at printing all of these items that are used to carry the boards and protect the boards and inspect the boards. So I really think there are a lot of opportunities that we're seeing right here at Productronica.
Now speak to me about or explain to me actually, how does that work in the factory? You have a machine or the printer.
Right.
How long will it take? You need to program it in, do the design, explain the kind of
sure.
The practical side.
Yeah, sure. So practically the way the workflow goes would be you'd have a process engineer or a manufacturing engineer on the floor. That manufacturing engineer usually is responsible to create the jigs and the fixtures and the tooling. So,
or at least to order them. Right?
Or order them, right? Yeah. So for some of the large companies we see, they have tooling shops or machine shops in situ, right? So you can take the CAD file of the device, design the jig or the fixture around that, and then for 3D printing you slice that STL file is usually the export from CAD, and then you can load the STL file digitally into a 3D printer and make sure you've got the material that you need, and then you can print the device right there on the floor. And we're seeing that start to happen actually in the U.S. We've got a great customer now in Central Texas that is working with us to 3D print jigs and fixtures for assembly, right in an EMS context. So it's starting to happen. We're excited to be able to talk about that more here in the near future, so stay tuned.
Okay.
But yeah, there's some exciting things that are coming down the pike.
No. This sounds interesting, and I'll be fascinated to kind of track it and follow, and hopefully you get to share that case study and we can help tell that story for you. But no, this is interesting. I think you chose a good show to come to get a good feel for the various applications of it, right? So, I mean, everything is here from a part perspective for that environment. So, Blake, thank you. Appreciate your time.
Thanks a lot.